Assalamualaikum warahmatullahi wabarakatuh. Hello guys, in this video I want to explain more about matrix. There are 7 points that I want to explain more with you. There are cofactor, determinant, identity matrix, inverse matrix, non-singular matrix, singular matrix, and square matrix. Okay, let's go to the first point. Cofactor is one of the steps in the process of finding the value of matrix. The cofactor of a matrix is a set of matrix elements that have been reduced by the matrix, which states that whether the element is positive or negative, in particular labeled is factor. To determine the matrix cofactor, you must find the following formula: that KAAB equals to minus 1A plus B times NAAB. That KA is matrix element cofactor, A is row A, B is column B, and A is minor matrix element value. For example, find the factors of the following minor matrices: negative 3, negative 6, negative 3, negative 6, negative 12, negative 6, negative 3, negative 6, and negative 3. The solution are as follows, and the cofactor is negative 3, 6, negative 3, 6, negative 12, 6, negative 3, 6, and negative 3. The second point is determinant. The determinant is the computable value of the elements of square matrix. A square matrix is a matrix that has the same number of rows and columns, so that if we draw the shape of the matrix, it will form a shape like square. So if the number of rows and columns is not the same, then we cannot find the determinant. The determinant of the matrix A can be written as determinant A, and the formula and example for finding the determinant are as follows. And determinant A, that A, B, C, D, determinant is A multiply D less B multiply C. And for matrix determinant of the order 3 times 3 is one way to determine the determinant of matrix 3 times 3 is using column rotation. For example, it's like this. The matrix A, we can find determinant with A multiply E plus BFG plus CDH plus CAG plus AFH and plus BDI. The next is identity matrix. The diagonal matrix with various diagonal elements having the value of 1 is known as the identity matrix. In general, the identity matrix will be noted by E. For example, matrix A with elements 1, 0, 0, 0, 1, 0, and 0, 0, 1. And matrix B is 1, 0, 0, 1. Next is inverse matrix. The inverse matrix can be interpreted as the inverse of a particular matrix. If a square matrix A is multiplied by its inverse, which is the square matrix A to the power of minus 1, it produces a matrix I, identity matrix in matrix multiplication operations. If the addition of two matrices, the sum of the two square matrices A and minus A will produce a zero matrix. For example, it's like this. The inverse of A is A to the power of negative 1 only when A multiply A to the power of negative 1 equals to A to the power of negative 1 multiply A equals to 1. Sometimes there is no inverse at all. Okay, how do we calculate the inverse? Well, for 2 times 2 matrix, the inverse is like this. You can swap the position of A and D, put negatives in front of B and C, and divide everything by determinant AD plus BC. Non-singular matrix. If the determinant value of a square matrix is not equal to 0, then the matrix has an inverse matrix, and a matrix that has an inverse matrix is called a non-singular matrix. For example, it's like this for matrix A, with the elements 2, 1, 1, 3. The determinant is 5, and for the matrix B with the elements negative 2, 9, negative 1, and 4, for the determinant is 1. It means that the determinant of matrix A and B is 5 and 1 that is not equal to 0. So we can conclude that matrix A and B is non-singular matrix and they have inverse matrix. And then singular matrix, if the determinant value of a square matrix is equal to 0, then the matrix does not have an inverse matrix, and a matrix that doesn't have an inverse matrix is called a singular matrix. For example, it's like this. For a matrix A with the element 2, 6, a half, and 3 per 2, for the determinant is 0. The determinant of matrix A is equal to 0. That means the matrix A is singular and it doesn't have inverse matrix. The last one is square matrix. A matrix that has the same number of columns and rows is called a square matrix. Square matrices have the order n times n. For example, for the matrix A with the element is 34, 56, 41, 45, 36, 37, 51, 32, and 46 is a square matrix of the order 3 times 3. And for the matrix B with the element 1, 2, 3, 4 is square matrix of the order 2 times 2. Okay, that's all my explanation about more matrix. If you think this is very useful, you can like and share this video for your friends, and don't forget to subscribe. And wassalamualaikum warahmatullahi wabarakatuh. See you in the next video. Have a nice day.